Welcome to the talk on strategic preparation for GATE Computer Science and Information Technology. Myself, Khalil Khan. Let me briefly introduce about myself. I have done PhD in Computer Science and Engineering and both postgraduate and undergraduate in the domain of Computer Science and Engineering. I have more than 23 years of teaching experience and more than 17 years of experience in GATE mentoring, tutoring GATE. Well, the objective of today's talk is to help the students in cracking GATE with a good percentile, good rank. Because many a times we observe that many students, they attempt the GATE exam without any proper preparation, without a strategic planning. So in view of that, what we thought over the period of years, what we have gained the experience in GATE coaching, we thought we should share with the students for the benefit of them so that they can achieve a good rank. Before I start the topic, let me briefly talk about the career aspects, because many a times when we teach in the class for the second and third year students, they basically ask the question, what should be the career aspects, what should be the career options? See, for this I generally say to the students of second and third year, because that's the right time for them to plan their careers, that there are two aspects, especially for computer science graduates. One is basically going for a job after after the completion of engineering, or maybe go for higher studies. Now, what to choose? What is the best possible option? See, there can be various options for that and various possibilities. I generally tell the students this way. For example, if your family background is economically poor or your family basically require your services, then it is better you opt for a job. And in case if the family can afford that you can go for higher studies, then I would always recommend that the pursuing students must go for higher studies. Now, when it comes to the matter of higher studies, again, there are options. I never need not say that you should always go for MTech or MS. You can even go for MBA. Because once you go into job, once you start working, it becomes very difficult to come back and pursue higher studies. So therefore, my personal recommendation to the student community is that basically, if you have the options, if your family can afford that you can pursue higher studies, you must go for higher studies, whether it is MTech or MS abroad or maybe even MBA. Because that will give an ample opportunity to plan your career better, and you can have a variety of options. Your level of maturity will be slightly better than in comparison to undergraduate. In that respect, I recommend that way. And moreover, many a times I also observe that people working in the industry and later if they want to come back, then it becomes almost like very difficult, if not impossible, to pursue higher studies for whatever reason they want to at a later point of time. So in all these aspects, this is what I generally recommend to the students. And of course, how to plan the career, we have a different PPT, and sometime later we can talk about that as well. The scope of this talk is basically to confine to the approach to be adopted for cracking GATE. So let's begin with this topic. What should be the ideal approach? If you consider GATE exam as a problem in the domain of algorithms, and as you are aware that solving a problem, we can have multiple strategies. So therefore, what should be the optimal strategy for cracking or solving this problem of attempting the GATE exam successfully and securing a better rank? I would say basically there are two influencing parameters, factors, the requirements to crack GATE. One is better planning, an organized approach, a strategic planning you can say. And the other key factor is the effective study techniques that has to be followed. By and large, in general, we observe that many a time students do not do that and end up in either failing or not qualifying, or maybe getting a relatively bad score and unable to crack it. So in that regard, we basically emphasize on these two aspects before you start the preparation. Before you commence the preparation for GATE, it is basically important that you should have a proper planning first, and the study technique that you need to follow should also be an ideal one, optimal, in order to crack GATE. Now, without planning, it is impossible to solve any problem, any project. So therefore, likewise, like for example, if you take up the game of cricket, for example, we have variety of models in that. We have test match, we have one-day internationals, and we have T20. We need to have a planning and we need to have a strategy for each of them. I cannot follow the same approach. So based on that, on the same aspects, we say basically that for the preparation of the GATE exam as well, we need to have a concrete approach, a proper planning for doing that. Otherwise, it will end up in a mess basically. Now, for organized planning, for proper planning, strategic approach, we basically start our discussion with the categorization of the students. By and large, over the period of years, we observe that basically we can classify the students into three categories, three levels. You can say level 1. So here my objective is not to demarcate the students based on their IQ levels or whatever. This is only a general observation. Level 1, I mean level 1 aspirants or level 1 students, I mean those who are above average in respect of their academic credentials, like having percentages of more than 75 or 80%, we call them as level 1 aspirants. Then comes level 2 aspirants, those who are having average credentials, academic credentials in respect of their percentages and IQ levels. And the third level category, third level aspirants are below average category of students, below average in terms of academic credentials. So a student basically has to evaluate himself or herself whether they do they belong to level 1 or level 2 and level 3, because for each of them we have a different strategy. You have to follow a different approach, and based on that only you can make a selection. What should be the approach that I need to follow for preparing a GATE to get a better percentile? Now, when it comes to after categorizing the students, what should be the next aspect? Now, see, as per the planning approach, you need to follow certain things. Like for example, we say first you need to understand the syllabus and the pattern of examination very clearly, because many a times we observe that the students do not read the syllabus properly, do not look at the syllabus properly, and end up in a mess without preparing well. And sometimes we also observe that the student do not know the exam pattern, what is the structure of the exam, how many papers are there, and basically what is the format of the questions, what is the format of the paper, etc. So in that regard, it is highly important as part of organized planning, what is the syllabus, and what are the subjects present in it, what is the pattern of examination. Then after that, the next important aspect as part of planning is very important aspect, prioritizing the subjects according to the weightage of marks. Generally, I tell the students when I talk in the class that the ideal approach of preparing is to follow, like we have an algorithm, a strategy called divide and conquer. So that is what we should try to do, prioritize the subjects, divide the subjects, like these are the strong subjects and these are the weak subjects. So the weaker subjects, how am I going to consolidate it? So prioritizing, dividing, that is very important. And this division can also be based on the weightage of marks. So you have to analyze how many marks are being given, what weightage is given to every subject, and based on that you can prioritize, you can divide. And then the third important aspect as part of planning is gather the relevant study material. I mean the textbooks to be followed, the internet resources, and the notes which have been prepared by earlier GATE rankers and so on. So gather the relevant study material so that you can study in a very organized way. Now, in this regard, I also observe one thing, that students most of the time they try to gather so much information, like they try to make up something like a big data, and eventually they will end up in not studying properly or not able to not able to formulate a particular approach of studying which material should I read, which textbook should I follow. So in that regard, it is better that you consult with the faculty, experienced faculty in this domain, or maybe those who have cracked GATE successfully. What subjects they have, what textbooks they have followed, what study material they have followed, and accordingly you can also gather that information. And the fourth aspect is a very important aspect again, where most of the time I observe that the students do not follow this and eventually end up in a mess. That is an action plan. For any task or any project, we require a master and articulating a effective action plan which is required for the preparation. You need to prepare basically a month-wise plan, a weekly plan and a daily plan based on the prioritization that we have done for the subjects which are present in the examination. So without an action plan, it is impossible to pursue the preparation of GATE. That's what we would say. Now for preparing action plan as well, again you can consult with the faculty who are involved into this domain, or maybe you can again consult your seniors, those who have cracked GATE successfully. And then you can also look into your aspect, because every person will have his own distinctness, will have his own basically an instinct to study. So based on this, you need to prepare your own action plan, because some people are good in studies during daytime and some people study very well during night time. So accordingly you have to make a proper and effective action plan. Let us elaborate on these four aspects in detail so that you can get insights as to how you should basically successfully prepare this. Now when it comes to the syllabus aspect of GATE for computer science and IT, here you can see the structure and understanding the syllabus. Broadly there are three aspects. There are three parts in the GATE paper of computer science and IT. One is general aptitude, which consists of two things. One is verbal aptitude and the other is numerical aptitude. That has a weightage of roughly 15 marks. And then the verbal part basically consists of English grammar, and then the sentence formation and sentence completion, critical reasoning and other parts. And the numerical computation, that is just normal numerical aspects like for example data representation, numerical data interpretation, numerical reasoning and numerical analysis and so on. So I believe that is not that much. If students pay a little bit of attention, if you feel that you are slightly weak in this domain, then perhaps you can you can successfully conquer this. So this has a weightage of 15 marks, and many a time those who are coming from rural backgrounds, I observe that they don't pay attention to this and eventually they lose the rank or they lose the marks. So it is highly important that you need to basically be well conversant with this domain of general aptitude. That will help in later stages as well when you go for placements, because many times in some companies they are basically looking into this analytical aptitude as well. So this general aptitude is quite important. The second part of this subject of the paper is the mathematics, which is normal mathematics, which you study at the +2 level, and then engineering mathematics, what you studied M1, M2 and so on. So that has a weightage roughly between 10 to 15 marks, almost for the past few years we have observed that. And the third and the most important part is the technical part, the core computer science and IT part. That has a weightage of around 73 to 75 marks. So that makes up to a total of 100 marks. Kindly remember that the bulk weightage, the main emphasis of the GATE paper is for the technical area. So you have to be very strong in that aspect, otherwise it will not be of any use. And last but not the least, with regard to this aspect, I would like to also emphasize that to secure a top rank, you need to master all these three areas. You cannot ignore one. Like you cannot say, many a times we observe this as well, some students say, sir, I am weak in maths, so can I ignore it? No, you cannot. If you really want to secure a better rank, then it is highly important that you must master all the three domains. Now coming to the second aspect, understanding the exam pattern, this is also very important. Prior to starting the preparation, you have to basically make yourself well conversant with the examination pattern. I'm just highlighting some of the points. As you can see, as you're aware, it is a computer-based online test. It is not a hard paper test as it used to be earlier. So it is purely computer-based online test. So that means you need to be familiar with the computer online test operation. That's not a big deal, I suppose. And the second thing is, it is basically a multiple choice questions and numerical type questions. Maybe a couple of years or maybe 3 or 4 years back, we used to have only multiple choice questions, but for the past few years, numerical answer type questions have also been introduced into the game. Numerical, I mean basically a small computation that will produce the answer in the form of some real numbers or integers. Earlier, I remember prior to 93, we used to have even fill up the blanks, blank type questions, which even used to have some words, fill the blanks with words. But thanks of this has been removed, otherwise it will lead to a lot of ambiguity. So right now we have only multiple choice questions with 4 options. One of them is only correct, and numerical type, both of 1 and 2 marks. Put together there are 65 questions, and the duration of the GATE exam is 3 hours. And do also remember that there is a negative marking of 33.33%, that is 1/3 for the wrong answers. And the negative marking is only for multiple choice questions and not for fill of the blanks. So that is with regard to negative corrections. Generally, the exam is held in the month of January or in the last week of January or February, first week. That is the general practice. But it may slightly vary, so therefore it is always advisable that you look into the organizing institute to get all these pertinent details. And for your information, let me also tell you that roughly around 1.29 lakh students have appeared for the GATE exam in the paper of Computer Science and IT. So that means you have to compete with these students. So this figure you should keep in mind while preparing. Coming to the third part, let me also elaborate with regard to the cutoff marks and the marks secured by the All India first ranker, so that you can get an idea as well. Here I have furnished the information with regard to past 2 years. Like for example, if you see 2016 and 2017, generally what I observe for the past few years, the cutoff for the general category is around 25, 26, 27, in that range. So that is the cutoff for general category. OBC it is slightly less, around 22 to 23, something like that. Like here you can see 2016 it was around 22.5, and same thing in 2017 as well. And for the other category like SC, ST, PWD, the cutoff will be slightly even much lesser than that. Like for example 2016 it was 16.6, and 2017 almost like 16.6, same thing. Now coming to the first rankers, the highest marks secured by the All India first rank holder. 2016 it was around 85.95, and 2017 it was around 86.38. And this general trend we have observed for past few years. Like the top marks will hover between 85 to 90. So just in case if you plan to secure a single digit rank, then you should always aspire to secure marks between 85 to 90. Then you can think of definitely a single digit rank or not more than 2-digit rank. Now coming to the further taking the discussion forward with regard to understanding the exam pattern, let me also tell you that 75 to 80% of marks are for numerical problems or numerical type questions, and 20 to 25% of marks are for theoretical questions. By theoretical, I mean you don't need to make any computation as such. Based on the concept which you study, with a little bit of application, you should be able to answer that. So it requires relatively much lesser time than in comparison to computation time questions. But you need to pay attention there that more than 75%, I would say, not less than 75%, the core aspects will be on numerical type. So GATE is not like your university exam where the type of questions will be described, defined, what, etc. It is purely an application of the concept. So you need to, later point of time, I'm going to further elaborate on that aspect, how you should basically prepare, what should be the approach for studying. and practicing the problems and so on. So it is not like your regular college exam or university exam. It involves a total understanding the concept and applying the concept in the domain of the problem and then trying to solve it. So 75 to 80% weightage is given for that, and 20 to 25% is only theoretical, like matching pairs and direct questions. Just to give you an idea, you can see the subject-wise breakage that we have observed, that we have prepared for the past 3 years, so that you can get insight as to what subject is having what weightage, so that you can pay more attention to that. In case if you observe that I'm weak in a subject which is having more weightage, then you can ponder upon it, you can think about it, and then try to pay more attention to consolidate that weaker subject. And here you go, you can see. From the technical domain, we have got 11 subjects, as I highlighted here. The first one to start, 2000 discrete mathematics. I have collected the data for the past 3 years. So roughly I can say this is the subject which is having the highest weightage in the GATE paper of computer science. As you see, 2015 there were 21 marks questions being asked in this paper. 2016 it was 13 marks, 2017 it is 15 marks. So roughly it is hovering between 15 to 20 marks. So those of you who believe, who basically observe that I'm weak in discrete maths, then you have to seriously think about this. So it is a very, very important subject, not only important from GATE, but if you plan to go for research, then this is one of the area where you have to think about it critically. So that's a very important subject. You have to pay more attention to this aspect, and it's not difficult as well. If you basically have some flair of mathematics, then you can easily catch up with it. Then comes theory of computation, as here we call in short FLAT popularly, formal languages and automata theory. It is also basically theoretical computer science, and that is also having relatively good weightage. Previous 2 years, 2015 and 16, it was having slightly less weightage, like in 5, and then later it improved 9, and 2017 it is 10. So again, I can say it will hover in general on an average between 7 to 10 marks, theory of computation. Again, a very important course, that is the foundation for the theoretical aspects. So this is again an important area where the student has to focus on. Then we have a small course on compiler design. So that has relatively lesser weightage, so around 3 to 4 marks or 3 to 5 marks. And sometimes we have seen questions being integrated with other subjects, compiler design and CO, and compiler design and theory of computation. So with that integration part also we can have slightly higher weighting. Then comes the databases, DBMS. Again, one of the core course of computer science. So on an average, we can say the average marks that you can expect for this subject between 6 to 8 or sometime 8 to 10, something like that. Computer networks, relatively very important subject in the domain of networking. So those of you who intend to build up their career in the networking domain, then this is one of the important areas. So that has generally a stable weightage between 8 to 10. Like 2015 there were 8 marks question, 2016 10 marks, and 2017 recent paper again 8 marks. Later point of time we are going to tell what are the further topics that we need to pay attention to this subject to consolidate. Operating systems, one of the core course again, that has again similar weightage, 7 between, it can hover between 6 to 10 or sometime even, because CO generally computer organization and operating system questions generally will be combined as well. So in that regard, sometimes even we have seen 14 marks from operating system, including some integration with integrated questions with computer organization. So not only important from GATE perspective, but from all other, because I generally say from my side, operating system is the operating system of computer science, all the subjects. So in all aspects it is one of the very important course, and most of the time I have been informed through my student that when they go for interviews, in the companies for placements or interviews for getting admission into MTech, if it is not a direct admission, then this is one of the subjects where students have been put most of the time the questions. So in all aspects I say this is one of the important subjects. Algorithms, which is I would say that is mandatory subject. You cannot think of ignoring it at any cost, because that is the key for computer science, for programming and all other aspects. That has weightage going between 8 to 15. Sometime we have even seen some occasions, sometime 15, 17 marks as well. So very important subject for programming and then software development and so on, because without any strategy, algorithm design strategy, you cannot think of any software development. So in that aspect, again, this is, and many institutes, including IIITs and IITs, when you go for interviews, then this is one area where the students will be grilled as such, algorithms. And a prerequisite for algorithm data structures having weightage of 2 to 4, 4 to 6 in that. Programming languages. So generally these three are the areas in the GATE syllabus, if you see, put together. But here we have segregated for students to have a clear articulation about the distribution of the marks. Programming language here is not learning any syntax as such, or not writing any program, but it deals with understanding the concept of C. So C is taken as a platform, and then they try to test the skills of the students with regard to programming aspects. Like they give a program and then they ask what is the output of it, where they try to test not only the problem solving, but necessary syntactic and semantic aspects of the language C. So this year, surprisingly, the weightage was given considerable to this subject. 9 marks of questions were asked in 2017. Generally, we used to see some 3 to 4 or 4 to 5 marks weightage is given to this subject. And the last but not the least, we have the digital logic and the computer organization and architecture combined together. Architecture is again a very important subject, and most of the time we see that the students have relatively difficulty in understanding the subject, even though this is one of the interesting subject if you pay attention to. That has again 2017 a lot of weightage was given, a lot of questions were asked from CO, 13 marks, and earlier it was between 5 to 7, 7 to 8, something like that. So I hope this has given you a necessary insight. What are the subjects that you need to focus on? What are the subjects that you have to pay more attention to and more focus as such? So roughly I would say at the end of this demarcation of the marks, that you need to pay more attention to subjects like CO, subject like operating system, network, DBMS and discrete mathematics. These are relatively very, very important subjects from the GATE perspective and also from interviews perspective. Now coming to the second part, what should be the ideal, optimal study techniques to be followed for the right preparation, for an ideal preparation, so that you can score well. The first aspect is, generally I tell the student that in short, GATE requires three-pronged strategy, as used to be said by Bruce Lee as well. Knowing is not enough, we must apply. That's the first thing he said. Knowing is not enough, we must apply. And having the will is not enough, you should do it. Like what does this mean? Like knowing is not enough, I generally, when I apply to GATE preparation, I say that knowing the concepts, knowing the subject is the first thing. But that is enough, that is sufficient for writing your university exams, college exam. But when it comes to the GATE, knowing is not enough, we must apply. That is what is very important in GATE. Knowing the subject, knowing the concept is not sufficient enough. In GATE, they basically test, are you able to apply those concepts in the problem given? And that is what is the primary crux of the GATE. Applying the concept in the given problem and getting the answer, that is very, very important. So first and foremost, the pre-requirement is you should know the concept. If you don't know the concept, then it's of no use. You cannot do that. So knowing is not enough, you must apply. Having the will that I want to write the GATE, that is not enough. You should do it. You have to do a lot of practice. You have to do a lot of hard work. So all these three aspects are quite important. So when you start the preparation, you have to basically see that first you are basically consolidating the theoretical aspects. Understand the theoretical aspects very thoroughly. and then you try to memorize the relative concepts which are necessary. Otherwise, if you just give a reading just like a novel, then that is not sufficient enough. You must basically thoroughly read, understand and memorize. And then basically what we tell is, based on the particular chapter or the topic that you have studied, that you have understood, you see the relevant problems, numerical problems, and then try to evaluate yourself whether I have understood those concepts or not. Because there are many study material, like in ACE also we have got the study material exactly based on that aspect. Chapter wise, topic wise, we have bifurcated the questions of previous GATE and other competitive exams and other questions. So that will help the student to know whether you are proceeding in the right direction or not. So take up the questions from the previous papers of GATE, from the exercises of the standard textbooks, and see whether you have understood the concepts or not, whether you are moving in the right direction or not. So then and there you solve the relevant problems, numerical problems of all the previous GATE questions before proceeding to the next chapter, next topic, whatever it is in the corresponding subject. As I mentioned, the study material of ACE has been designed primarily exactly in this particular order to facilitate the students for a better understanding and better preparation. And it is equally very important that you should revise the theoretical concepts at regular intervals of time. That is highly important, because you need to prepare for 11 subjects, so it's not easy. So for that, what I also used to say while preparing the topics, you should also make a habit of writing down the notes. Notes, I don't mean you have to basically prepare a detailed note. The important points, important formulas, and then you keep it. That depends on individual aspect, how you basically can remember very well. So you should take a small note, précis notes, and then so that just at the time of revision you should be able to recollect everything. So revising the theoretical concepts at regular intervals time will help you consolidate the formulas, the hypothesis, and other aspects. So prepare the notes and consolidate the understanding. And once you complete a good amount of the syllabus of a particular subject, you can even try taking some online test. And when you take the test, don't take it very casually. You have to be very serious, because test series will enable the student to test themselves, to assess themselves whether they are able to solve the problems in the limited amount of time or not. So in this regard, I would also like to add a point that many a times when I teach, I also observe that when I give a problem, students might have understood the concept, might get a feeling that yes, I can solve the problem, but they don't practice it. They don't work out in the class, because we can do it. It requires some calculations. Who will do the calculations? See, that is a grave mistake if you are doing. If you are not habituated to computations, then you will really feel the heat on the day of exam. Many a times I observe that if you are weak in mathematical computations, then you have to pay a lot on the day of exam. This is based on the feedback given by the students that I am telling you. So it is highly important that you practice, you evaluate the computation, because on the day of exam you will have the additional pressure of the exam. So you repeatedly try to see whether what I have done, what I have made the calculations, is it right or wrong, and that is going to waste your time. So remember that you practice the questions and take the online test series and manage your time and keep on assessing yourself whether you are moving in the right direction or not. And some of the useful tips that will help you in the preparation. Now when the question is given, you have to use the standard values of the constants and hypothesis in the question. Don't make any assumptions from your side, or don't take any values from the other side. Like just to give a simple example, I say in the context of for example scheduling, CPU scheduling, whenever there is a tie between processes with respect to the criteria like arrival time or burst time, then which process should be considered first? So there is no hard and fast rule for this. So generally the tie breaking rule will be specified in the question. That's what I observe most of the time. So what we teach during the lecture session may be different, and what will be given in the question will be different. So I generally advise the student in that aspect that you read the question thoroughly, see what is the rule, what is the hypothesis given, and what is, if at all, if a constant is given, then use the value which is specified in the question and try to work out the answer, and don't make a silly mistake in that aspect. And yes, it is also very important that you need to practice yourself with virtual calculator, because you cannot go to the examination with your own scientific calculator. So therefore, for some time, you make yourself well conversant with the operation of the virtual calculator. And once you finish off the study of all the subjects, make sure that you revise 2 to 3 subjects at a time. And while preparation also you can do that. I mean, finally it all depends on the your ability, your distinctness, your instinctness, how good you are, what good you are at. So based on that, but generally we advise that you concurrently make a study of 2 to 3 subjects so that you don't get bored up. Or some people say, no sir, I will complete one subject, then I will take up second, like for example batch processing, serial processing. That is up to you. Generally I generally tell the student that you should go for multi-programming, basically going for 2 to 3 subjects at a time. That will optimize your time. And yes, it is quite important that during the preparation, in order to utilize your time more effectively, you give regular breaks during the course of study, maybe 2 to 3 hours. If you continuously study, give a break half an hour time, go out, relax. So that will energize you and refresh you, rather than sitting continuously. And many a times in my terminology, I used to say perform context switching, be there and again come back and try to waste the time. And have a burning desire to derive energy. Otherwise, if you get demotivated, then it's not good for the preparation. So you should have a very firm burning desire and a consistent determination in order to prepare for GATE, because the journey is too long. You have got 11-12 subjects to prepare, so therefore you need to maintain your rhythm, enthusiasm to the highest possible level at regular intervals of time. Many a times I observe students come with an enthusiastic zeal in the beginning, and as we proceed with the course, they try to lose out the enthusiasm and eventually drop out. So that should not happen. So maintain the consistency in preparation. Avoid distractions. That is again a very important aspect, a very useful tip. Avoid distractions like social media, and focus on your target. That is highly important, because many a times we observe during the class as well, the students carrying the cell phone and trying to browse the net, and that will have a drastic impact on your preparation. So try to be aware for some time from these distractions, and be focused on your preparation. That is very important. Even if you need to browse the net, you should browse it only for the purpose, like for example browsing for getting relevant information, or relevant if at all you are trying to search for any topic, then that is okay. Do some regular exercise, because this will require a lot of preparation, lot of work. So therefore do regular exercise, eat well, sleep well, and you have to maintain yourself in good health for a good preparation. And be always optimistic, never get demotivated, because demotivation will lead to chaos. So always have always a process active in your mind. That's what I say, that I will do it, definitely I will do it. Wherever you are living, whichever room you are living, for example, you just put a small paper in front of you that I will do it, and keep on looking at it at regular intervals of time. Definitely that will basically give you the optimism necessary for preparation. And a very important aspect, generally I find this among the students, don't compare with your peers or with anyone during the preparation. This happens in the class, outside the class. Many a times we find, sir, I'm unable to score well, whereas my friend, even though he doesn't study, he is getting more marks than me. See, every individual has his or her distinctness, I say, the instinctness, uniqueness. Some people study effectively in less time, some people study effectively in more time. Some study well during daytime, some study well during night time. So you should not compare. You should try to explore yourself, what good thing you are at and you try to exploit at that. Because I very strongly believe that God has given to every individual it's his or her own distinctness. So in that regard, you have to basically analyze yourself, assess yourself, what good I am at, and then you try to exploit upon it. Definitely you can do that. Never try to compare. In this regard, I just at a lighter side, I would also like to tell that many a times I observe in the class, while teaching in the class, I observe, like I discuss some topic, while I'm discussing some topic, I observe a student, for example. Maybe for some reason he or she does not follow the topic. Then most of the time I observe that when he doesn't understand the topic, rather than making an effort to understand, or rather than asking the faculty, concerned faculty, to repeat or address the problem again, they would try to look at their friends. Maybe somewhere else his or her friend is sitting, and then they try to ask their friend, have you followed? He also or she also would say, no, I have not followed. Then this fellow will be very happy. My friend has not followed, I too have not followed, so let us be very happy. No, this should not happen. Make sure that every topic, I'm not saying subject, every topic of the subject you have to consolidate. Sometimes some students come and ask, sir, I'm not comfortable with memory management, can I ignore it? I say, forget about the subject. You cannot afford to leave a topic. Now if I tell that, okay, you leave file system, you leave memory management, then finally he would start getting disinterested and say, okay, operating system is, I'm not interested, let me leave it. Or if I say, for example, if he insists on saying, sir, what subjects are important, what are not important, if I say, okay, you leave discrete mathematics, it's theoretical, theory of computation, you leave it is theoretical, don't pay, you can take it at a lighter side, if I say like that, then perhaps he may go to other faculty and say, sir, what subjects according to you are not important? If that faculty say this subject is DBMS, you can leave, operating system you can leave. So like that, if he approaches all faculty, then eventually he will end up in saying, I don't have to prepare for GATE. So remove that process, kill that process, saying that what subjects I have to leave, what subjects I have to pay more attention to. If your target is basically to excel in GATE, get a single digit rank or get a rank within 100, then essentially you have to master all the subjects. Okay, so that is a very important aspect. Then coming to the types of questions in general, what types of questions are asked in GATE? Now, based on the previous analysis, we have formulated the following types, like for example, theoretical questions, simple questions, very straightforward, which may include like a set of statements are given, and then the matching type questions, and then you have to see, make a correct matching or make a correct selection of the among the given statements. This involves a direct concept. I generally used to tell the students, these theoretical questions are those questions which can be solved in order of one time. It doesn't require any computation, does not require you to think much, in order of one time. And at the time of writing the exam, I generally used to tell the student that you should try to attempt such questions first, so that even if there are some around 8 to 10 questions of this type among all 65 questions, for example, these are 8 to 10 questions, then if you solve them first in order of one time, then perhaps your confidence level will get improved. So you will have more confidence, your pressure will come down, and then you will be at ease. So that will give an ample opportunity to work out the more difficult questions which are going to follow in the paper. Then there will be short numerical problems that may require around 1 to 5 minutes of time. So this will require not much of thinking, perhaps, maybe a small application of the concept. You may be needing some formulae, you need to look into the question and get the relevant data, and then substitute and try to get the answer. Relatively a small amount of thinking is required, like perhaps you can say order of polynomial time, for example. And it is always desirable that in the beginning you should try to avoid solving lengthy problems. Based on my previous experiences from the students, I observed that some students take up initially long questions, lengthy questions, and then they spend more time and eventually get frustrated, and as a result they will spoil the other questions which are very direct and they would have done. So it is always desirable and advisable that you should avoid lengthy questions in the beginning. First you solve direct questions, theoretical questions which we said, short numerical problems, and then you should come back to the long questions that require lengthy derivations or lengthy calculations. Focus on short derivations that involve fundamental concepts, avoid solving questions that require longer derivation. That's what I said. Now just to give you an idea, here I have taken some sample questions of a variety of types from 2-3 subjects to emphasize on the point that I said what type of questions are generally asked. Like for example, if you consider this question taken from operating system, because this is one of the subject for GATE but also for in the computer science program at undergraduate level and postgraduate level. A simple question related to threads, which I say under the category of direct. Say a question related to thread. A set of 4 statements are given with regard to user level and kernel level threads, and they ask which of the following statements are true. So unless and until you are very sure about what is a thread and what are the types of threads and what are the characteristics of the types of threads like user and kernel level threads, this question cannot be answered. If you know very clearly what are the characteristics of user level and kernel level threads, I am sure you can answer this question very directly in order of one time. Like context switching is faster with kernel supported threads, it is incorrect. Context switching is super faster with user level threads. And the fact that a user level thread will get blocked upon the requirement of any IO operation or execution of any system call, that is true. If you know this concept, then the statement holds true. Kernel supported threads can be scheduled independently, yes, it can be done. User level threads are transparent because that is one of the property of user level threads, so that is transparent to the kernel. So if you have studied all these aspects, then this question I am sure you can solve in order of one time. So that is a question. Likewise, a simple question to give an idea of what do you mean by computation and the application of the concept. Fork is a system call which is responsible for creating a child process. So this question was asked in previous GATE couple of times in different ways, like a set of fork system calls are given in series, I say in series. Then how many number of child processes or new processes get created altogether when we execute this program, perhaps in a operating system environment like Unix or Linux. So if you know that when a series of statements, fork system calls are given, then the formula, if you have been taught, the formula is the total number of processes that get associated with the program is 2 power n, where n is equal to number of fork statements in series. So I have 3 fork statements in series, so total number of processes would be n, 2 power n, and if you say number of new processes, that is child processes, then I have to subtract 1 for the parent, so therefore the answer would be 7. But here I would like to emphasize on the fact that this formula 2 power n or 2 power n minus 1 holds when the fork statements are in series. But suppose if the fork statements are put under if then else condition, then this formula does not hold. So therefore here what I wanted to tell you, not only the concept but also the application of that is quite important. Suppose if you just understand the concept by listening to someone or watching somewhere on the internet that if I have 3 fork statements, the number of child processes are 7, 2 power n minus 1. If you apply the formula same way, when the program is having and the fork statements are present in the program in if there else, then the concept does not apply, the formula does not apply. So therefore not only the concept but the application of the concept is also very important. Another question we can see from the one of the previous paper, the process state transition diagram is given and then some again first statements are then. This is again an application as such that require the concept plus the application of the concept. The choices or the options are related to, like for example, if a process makes a transition D is going from running to terminate, it would result in another process making transition A immediately. Means, for example, when a process completes its execution running on CPU, are we going to load a new program for execution immediately? That again is an application, you have to think, is it a compulsion that I should load it immediately? Immediate may not be a pass. Immediately is basically like a compulsion. It mandatorily you have to load. But if I don't have a new program to load, then what am I going to do? So, but in case, for example, in the question, if they say always there are some processes available in the job queue or input queue to get loaded, then perhaps this statement would have become true. Like that, the second statement, if you see a process P2 in block state can make transition E. Transition is going from block state to ready state, while another process P1 is running state. Quite possible. When a process is running and some process can complete its IO operation or may satisfy the event for which it was waiting, it can go into the ready state. So that is a valid transition. Then the last two options are dealing with the preemptive and non-preemptive. Whether this process transition diagram is an illustration of a preemptive multi-programmed OS or non-preemptive multi-programmed OS. In the non-preemptive one, we are not going to have a transition from running to ready. That is non-preemptive because there are two conditions for non-preemption. The process running on CPU would relinquish the control of CPU voluntarily in the case of non-preemption. And there are two non-voluntary conditions. One is when it complete or when it releases the CPU for its own IO requirement or execution of any system call. That is called an event. But for preemption, the running process may be forcefully deallocated, may be asked to relinquish the CPU forcibly, and that is what is happening here. So therefore, it is very clear that this process state transition diagram is a clear illustration of a preemptive based multi-programmed operating system. So that's how you need to argue and then reason out and then make a correct choice. So this also can be done perhaps in order of one time if you are very, very thorough. Otherwise, you have to think on these aspects and then come to a conclusion. Recalling and computation. This is a question related to computation of the effective memory access time in a paging system environment, for example. It's a direct question that requires a computation to be made. Page fault service time is given. Memory access time is also given. Page fault rate is given. He is asking what is the effective memory access time. So to solve this question doesn't take much time, provided subject to the condition that you remember the formula for what effective memory access time, and that's what we said. While preparation, you should make a note of these formulas and revise regularly so that you can work out these questions more simply in perhaps 1 or 2 minutes, not more than that. The formula is effective memory access time is equal to memory access time into hit rate plus miss rate, that is page fault rate multiplied by the service time. That's all. If the data is given, you have to substitute in the formula and you can get the correct result. A question related to matching pair. Again, for this, the underlying concept should be very clear to solve this. Sometimes it may lead to confusion. Sometimes I've even seen in GATE that the list one or the left hand side may match to multiple options of the left hand side may match to the same option of the right hand side. So you have to be careful with that. Like here, it's a very direct one. DMA IO operation is related to disk. The cache is high speed RAM. Interrupt is basically for printer, and condition code register is for the arithmetic logic unit. So that's how you can apply. Again, a question from programming in the domain of recall and application. A simple structure is given having two member fields, one is integer, the other float, and then we are declaring like struct node star s and 10, an array of pointers to structures. So what is the best possible statement that describe this declaration? An array, each element of which is a pointer to a structure of type node. A structure of two fields, each field being a pointer to an array. There is no pointer like that. A structure of three fields, there are no three fields. An array, each element of which is a structure of type node. So array of pointers, an array, each element of which is a pointer, because this is an array of pointers, each element is a pointer to a structure of type node, so that is the correct option. So many times questions like this also have been asked in GATE. Like that, as I mentioned in my earlier discussion, some questions in programming are related to producing the outcomes. So for this also you should have some flair of pointers. Majority of the questions are based on pointers in C and structures and combinations of pointers and structures, pointers and arrays and so on. Like this is also a similar question. So if you have worked out similar problems, then I'm sure you can work out this question as well. What is the output of this program? So in that case, you should know P is a pointer to a character pointer, and C is basically an array which has been initialized to the string by name GATE 2017. Then when I execute this program segment, what is output it is going to? So I have some computation there, P plus P of 3 minus P of 1. P is a pointer and we are trying to access it like an array. So what does that mean? So unless you know what is the notation for P of 3 and P of 1, then what constant value is going to come which I need to add to P so that I can print the string from that particular point. The questions like this are also important. Again, a question from C that requires a good amount of application and reasoning out. Three program segments are given, P1, P2, P3. Each one you have to analyze, you have to understand and tell which of these segments are likely to create problems with pointers. So you have to understand what is the problem present in each of them. Like for example, if you see P1, the code present in the segment P1, it's a function returning an integer pointer and not accepting any argument as such. I have a local variable by name x initialized with 10. I am returning the address of local variable. So therefore, this is a flaw. You cannot return the address of a variable which is present locally into that. That will lead to problems like dangling pointers basically, because memory get deallocated for local variables which are present inside the function, and if you return the address of it, then it will lead to the problems. So that is a problem in P1. If you see the code of P2, the function g returning pointer, again integer pointer, I have defined a local pointer there by name px of integer type, and I'm saying star px, dereferencing it. I mean trying to assign some value through the pointer star px equal to 10 and return px. The problem there, if you observe, is basically that you are any pointer that you define, that you declare in the program, must be initialized with the address. So the flaw in this problem in this program segment P2 is that it is uninitialized pointer. You have not initialized pointer to the address. So if you understand that, then perhaps you can easily recall and apply it over here. Whereas if you observe the third segment P3, again a function returning pointer without accepting any argument, I have a pointer and then I am allocating memory segment of type integer to it through malloc, and then it is initializing to some value like 10 and returning px. So absolutely there is no problem with this. This is a clear illustration of dynamic memory allocation. So that's how you can apply, argue, arbitrate, and then reason out and make the appropriate choice. Now with regard to concept and reasoning in application, there is a question from algorithms. Two functions are defined in the limits of the values of n as given here. G1 is defined as some n cube and n square depending on the range of, and then G2 having some functions. Now they ask which of the following is true with regard to the O notation. So unless you know the definition of big O, then you cannot work out the question whether G1 is in the order of G2, G2 is in the order of G1. And again, for what is the smallest range of smallest value of n from where you can establish the fact that G1 is in the order of G2 or G2 in the order of G1. So these types of questions require a little bit of thinking, and then you can work out such questions. Again, direct question and computation. A simple graph is given having 8 edges. The edge weights are integer, and that too it is stipulated that the edge weights are distinct. No two edges will have the same cost. It say that the minimum spanning tree has already been constructed, where the marked edges indicate the edges which are present in the spanning tree, minimum cost spanning tree. And the weight of that, if you make a calculation, 15 plus 2 plus 9 plus 4 plus 6, basically that is around, he says 36. Whereas the other two edges are not given, the edge costs are not given. So he is asking what is the minimum possible sum of weights of all 8 edges of the graph. That means in simple we need to find out what should be the edge cost of AB and CD. So this basically requires some insight to work out. Many a times I found students, when I give this question, when I ask the students to work out, they try to adopt a hit and trial method. But this question, I say, many people are perhaps unaware that they generally say there are two algorithms for solving the problem of minimum cost spanning tree. One is Kruskal's method, the other is Prim's method, but this question is not directly based on them. There is another method for solving or determining the minimum cost spanning tree called Dijkstra's method. So this question is a direct application of Dijkstra's method for minimum cost spanning tree. Many people generally are of the view that Dijkstra's algorithm is only for single source shortest path, but let me tell you that we have Dijkstra's algorithm for minimum cost spanning tree as well. So we can apply that and get the answer very easily. So this is a fill of the blank question. Like that, without going into much details, we can have again questions from data structures in the similar pattern like that involves some application of concept and computation. So I hope these questions, sample questions, might have definitely given an idea to you as to what kind of preparation is needed, what type of questions are asked, and you have to analyze yourself, you have to assess yourself whether the kind of knowledge that I have right now, is that sufficient enough to work out problems like this. Then based on that, accordingly, based on the strategies that I have discussed, the tips that I have given, you have to apply and then prepare so that you can have an effective preparation. I would also like to talk about the subject-wise details in terms of the weightages, which I have already indicated earlier, in terms of the relatively important topics, and then the textbooks that in general are to be followed for that. Starting with discrete maths, as I mentioned earlier, the average marks will hover around 15 to 20 marks, and based on the previous questions, we say that the important topics from this subject includes the logic, mathematical logic, the probability, the set theory and algebra, combinatorics, and elementary graph theory concepts, linear algebra and calculus, including the engineering mathematics part here as well. And there are innumerable textbooks for discrete mathematics. Some of them prominently are being displayed here in the side, you can see. Tremblay and Manohar and Rosen and Grimaldi is also one of the textbooks. Moth and Candle, that is one of the prescribed textbooks across many colleges. So some of these textbooks you can follow. And it is always desirable, highly desirable, that for every subject it is mandatory, it is compulsory that you must read the textbook once when you start the long-term preparation. If it is short-term preparation, then of course the strategy has to be slightly different, but when you are preparing for long-term, it is highly desirable that you must read at least one textbook. I am saying desirable is 2 for some topic, but in that case again, when you are when I say read the textbook, doesn't mean you have to read from the first page to the last page. Again, you have to be very judicious in terms of selecting what chapters am I supposed to read. Don't try to waste the time in reading again from the first chapter to the last chapter. Look at the syllabus, look at the topics which you feel are slightly inconvenient or slightly weak, and then you try to emphasize on that topic, on that particular chapter or topic as well. Likewise, theory of computation, the weightage goes around between 9 to 10. And basic definitions, the concept of relations, finite automata, DFA, NFA, regular languages, CFLs, context-free languages, push-down automata, Turing machines, recursive languages, complexity theory. These are some of the important topics in this particular domain, and there are a number of textbooks like Hopcroft and Ullman, Peter Linz, and so on. Compiler design, weightage around 4 marks. Some of the important topics: lexical analysis, context-free grammar, syntax-directed translation, and code generation. And you have Alfred Aho, Ullman. There is an important textbook that is more than sufficient enough for these simple topics. Programming languages is basically dealing with the concepts of C. I don't have to elaborate much. Some of the topics. But in particular, I would say for programming, you have to pay more attention towards pointers, arrays, and structures, because these are the areas from where questions have been asked relatively at a higher side. And you can follow textbooks like Kernighan and Ritchie, and then Yashwant Kanetkar. And there is one good book called Puzzles in C. Well and Fure. I would tell you must refer this textbook because it contains a lot of good puzzles in the form of programs, segments or programs given and asking what is the output. Same like the pattern of gate. Data structures, of course, all topics of data structures are quite important. So arrays, tags, queues, trees, graphs, hashing. And you can either follow Sahani textbook for it or Farhausen. Both are important. Coming to networks, marks hold on an average between 8 to 10. And the topics of importance include the LAN technologies, switching, IP protocols, routing protocols, and application layer, network security. You can follow Peterson or Peterson-Davy or Farhausen or even Tannenbaum as you wish. Coming to computer organization and architecture, computer arithmetic, memory organization, pipeline, CPU organization, control unit design, secondary memories, register allocation. These are the important topics with regard to the subject of CO. And with regard to textbook, you can either follow Maurice Mano or maybe Hemasher or William Stallings. William Stallings is also a good book for CO. May not be for the operating system, but for CO it is relatively a good book. And digital logic is relatively a simple course and interesting as well. Number system, Boolean algebra, K-maps, combinational and sequential circuits are the topics of interest. And Maurice Mano, I think that is more than sufficient enough. You don't have to look for other books and waste your time. Algorithms, the analysis in terms of time and space complexities, the asymptotic notation. Generally, I say one question, most of the time I say would be compulsorily asked in GATE with regard to asymptotic notations. Then followed by 3 design strategies, namely divide and conquer, greedy method and dynamic programming. Of course, there are other 2 strategies you might have studied at the undergraduate level in your college or university, that is backtracking and branch and bound. But here, as per GATE curriculum, we have only 3 strategies, and all 3 are equally important. Then optimal binary search tree as part of dynamic programming. Corman is one of the excellent book for algorithms. Apart from that, there are other books as well, like for example, Algorithm Design by Tamassia and the regular textbook Fundamentals of Computer Algorithm by Sahni. Many a times I observe that the IT students in different universities, they do not have a course on algorithms and face a lot of difficulty with respect to this subject. So in that perspective, I advise the students, in particular those who have not studied the algorithm course earlier, you can start from Fundamentals of Computer Algorithm by Sahni, and then you can switch over to Corman. So that approach they can follow. For operating system, the important topics include the process concepts, the scheduling part, the synchronization, which is the core part of the operating system. And within synchronization, again, we say the semaphores and the monitors, these are the important topics. The memory management and virtual memory. Virtual memory is important not only from GATE perspective but from implementation aspects as well, because there's a technique which is popularly or mostly used in the contemporary operating systems. And what is virtual memory, implementation of it, this performance issues and so on, file system and device management. Some aspects of device management overlaps with that of CO, so you can optimize the time with regard to that chapter. Galvin is one of the excellent book, and if you read Galvin, that is more than sufficient enough. But just in case if you want to read other textbooks, like you can do so, Modern Operating System by Tenenbaum, that is also a good book. But there are innumerable books. These 2 books are more than sufficient enough. Remember, the weightage of this is also 8 to 10 marks. Similarly, database management systems hover around 6 to 8 or maybe sometime 8 to 10. ER diagrams, functional dependency, normalization, that is a very important aspect. The query language, structured SQL, generally questions are asked from there most of the time. Relational algebra, relational calculus, transaction and concurrency control. Some topics of this overlap with that concurrency control and synchronization of operating system as well. So that is again an important domain. And like that, you can also have file structures and the indexing part. Syllabus charts and Sudarshan is a good book for databases, I would say. In addition to that, you can even refer Elmasri and others. Now, continuing with the organized planning, I would also recommend that you must study only the standard textbooks, internationally acknowledged textbooks, not the local textbooks or study material. It is highly important that you read the standard textbook and understand the topic, understand the concept, rather than just do not try to read it from the perspective of solving the problems alone, because assimilating the concepts is highly important, not only from the perspective of GATE but also from other aspects which I mentioned, maybe facing interviews for companies or interviews for securing admission in IITs and ITs and so on. And make sure that you have definitely worked out the previous GATE questions and understood the concept underlying. I'm not asking you to remember the answers for the GATE question, that will not help you. Understanding the working principle, the working mechanism, what concept is being used and how are we working out the question. I also advise the student generally at the time of preparation and solving the questions that never adopt the policy of working out the questions by looking into the answers. This is a very common habit. I'm sure many of us follow that. We are habituated, like I read the question, for example, I say some question, so and so, and I look at the options A, B, C, D. And I see, okay, I think I'm inclined towards option B because my mind start getting inclined towards that. So based on whatever concept I have, little bit of concept I have with regard to that question, I immediately come to understanding that maybe I think the answer of this is B, and human mind, I'll always say, is very anxious and curious. So we would like to verify what I'm thinking is right or wrong. So the moment key is there, I try to look at the key and then see whether what I'm thinking is right or wrong. Suppose if it is B, you are happy. If it is not B, if it is given as C, then you try to see how to get C, option C, and that way you try to mix up. So never do that. You try to work out the question exactly by understanding the concept, by applying the concept. So that way slowly you try to improve your confidence levels towards problem solving. That is highly important. Do also watch the standard online lectures like NPTEL and so on from standard institutes like IITs and so on. That will also basically add on as a supplement to your preparation. And maybe it's a individual choice whether you learn the whole subject by watching the videos or you may not be able to watch, you may not be able to learn the subject. That is an individual choice, I leave it to you. But definitely watching the videos according to me, will act like a supplement if not learning the full subject. The ACE Engineering Academy material, study material also has been designed and has been made sure that it covers all the aspects, all the concepts, so even you can follow that and try to understand the concepts. And as I mentioned in my earlier discussion, that preparation of an action plan that suits you in the best possible manner is highly desirable, highly recommended and needed, I would say. You have to make a plan, pen down and make an action plan monthly, weekly, that this month I am going to target these many subjects which I am weak at or maybe I am strong at, and depending on your abilities. And then weekly plan, then daily plan, and every week you should try to assess how much you have attained your action plan, whether you are in line or not, or where you are going wrong. And for this, as I mentioned, you need to consult your seniors or the faculty in that domain and then prepare an action plan and reevaluate yourself at regular intervals of time to know whether you are in unison with it or not. That is very important. Make sure that you try to make at least 3 revisions before the final exam. That is recommended, of course not necessary. And as I mentioned, you have to stick to the timetable that you have prepared, otherwise you will miss the chain. Then finally, I would like to talk about the objectives of the coaching program that we have in ACE Engineering Academy. The coaching program has been designed not only for targeting GATE, but will also for other aspects. Like for example, of course, the main objective of the coaching program is to help the students write the GATE exam and excel and secure seats in IITs, NITs and other reputed institutes. But it will also strengthen the subject knowledge, because we start right from the grassroots level without making any assumption whether you studied the subjects or not. Right from grassroots level, we start from origin zero and try to reach you to the heights with which you can basically crack the GATE questions comfortably. It is also targeted towards writing TIFR. I'm talking about the computer science program basically. TIFR, Tata Institute of Fundamental Research, the PG and the doctoral programs. Many students who have undergone coaching here have been successfully be able to crack the TIFR exam, and they have pursued the programs. It also helps for those who intend to write the UGC NET for teaching positions in various government colleges and universities and institutions. And it will also help you to crack the PG CET exam, which is conducted by various states for securing admission into MTech in their local universities. Will also definitely help, because the level of DRDO and ISRO exam is relatively lesser than that of GATE, so naturally it will help you to crack those exams also. And definitely it will facilitate the preparation that we impart here. The coaching that we impart here basically will help the students to face the interviews and the selection process of product-1 companies, product-based companies. This is based on the feedback that we have got from the students who have successfully been able to enter into the product-based companies, because the orientation is not just towards GATE, but consolidate all the foundations and build up a total personality to face up all these challenges. And lastly, I would also like to make a mention that recently you might also have been, you might have seen that The government is planning to make GATE as an exit exam, so in that regard, the coaching will definitely be useful for cracking the GATE exam to get your degree. Finally, last but not the least, I would also, because many a time students ask whether to prepare based on classroom coaching or based on online coaching, which I in short call it as brick versus click. Brick, I mean the classroom, click means the digital mode or the online mode. So it's absolutely or purely your own choice, but by and large, based on the previous experiences, basically, if you each one, I would say that each one has its own pros and cons. Like the classroom coaching, I would say, will provide an environment, a platform where you can interact with your peers, you can interact with the faculty online, and then you can clarify the doubts. Because many times I observe students who are average, and then based on the interaction that they have with their peer groups, they energize themselves and they come into a competition mode, and that is necessary for the preparation, that is very necessary for improving the personality. Whereas the online mode, you have to basically in the leisure mode and then try to watch the videos, and then, but even then also I am not saying that online will not be of any use, because tomorrow the AS may also be launching online mode, then you cannot say, sir, you are talking about like that. So it's a pure individual choice. You will have an opportunity to watch the video multiple times, but you will not have opportunity to have a direct interaction like a live class, which is possible in the classroom coaching. So not going into much of those controversies, I just say it is your individual choice whether to go for classroom coaching or online coaching, and then you will also have to say whether I require coaching or not. I never said, I am not saying that coaching is mandatory. For those whom I said level 1 aspirants, absolutely, if you are sure, if you are confident that you can, by looking into the questions, by looking into the subjects, you can make a self-analysis of yours and see that I absolutely don't require, then definitely you should never go for coaching. You can prepare on your own. But those who assess themselves to be under level 2, level 3, it is recommended that you take some form of coaching so that you can excel yourself, and then it's a matter of choice. So there is no compulsion as such whether you should go or not. So that was the intention of the talk. Hope you might have assimilated something out of this talk, and I thank on behalf of ACE Engineering Academy for watching this presentation.